Find all values of theta. As I see this, I don't like these denominators. I can do nothing about this because it's protected by cotangent. But these denominators of 2 are exposed. So let's multiply every term by 2. This would become 8. If I multiply this by 2, it knocks out the half. Multiply by 2, knocks this out. Multiply by 2, there's a 2 there. While we're at it, we'll make a u substitution for this expression inside. So we'd get back let's do that first. So we get back, we multiply by 2. Let's make sure this was not botched. Let's see, multiply by 2, 8. Multiply by 2, gone. Cotangent stays. This is u. Multiply by 2, gone. These two pieces collapse. A 2 would be there. This becomes u. Looking at this, the 8s can undo one another. Maybe we can subtract this cotangent to this side and move this square root 3 to that side. Okay. Then we have options. We can turn cotangent into tangent, or we can leave it as is. And recall on your identities that cotangent isn't cotangent x over y. So maybe we can manipulate this number to make it look like x over y. So initially, I could drop a 1 below. And then I could make further changes. I could rewrite this fraction as okay, right? So what just happened? Numerator and denominator each got divided by 2. This was done to make this look more familiar, because x over y, so this is x and this is y. These are coordinates on the unit circle. So if you go to your unit circle, you would observe that this is an x coordinate and this is a y coordinate. Where? Well, initially, right here. So that is one value of u. So u equal, that location is 5 pi over 6. But what you can do is you could swing the negative from top to bottom. And then go back to the unit circle and tell me where this is what happens. Where do you see an x coordinate this and a y coordinate that says that? That would occur here. So another potential value of u would be 11 pi over 6. But the directions did say to find all values of theta, all of them. So you'd go plus or minus 2 pi k. I'll just use k. Notice that we included the plus or minus idea as soon as we could. I did not wait for the end for theta. I did not wait for the very end to go plus or minus 2 pi k. I did it as soon as possible when I found the values of u. Now, if you want to get fancy, we can get fancy. These two values of u are diagonally opposed from each other. So you don't have to submit two answers. We can actually merge these two into one, where we begin at 5 pi over k. Or excuse me, 5 pi over 6. It's still plus or minus. But instead of making a full spin, we can make half a spin every time we move. So instead of 2 pi k, you can say 1 pi k. This result alone will compensate or account for all of this. So that's us just getting fancy. If you don't like that, you don't have to. You can continue with these two. But I choose to work with this. So this is the value of u, which goes in here, so we can find theta. Well, let's finish this off. So all of this here gets placed in for u right there. So now we want to find the value of theta so we can be done with this problem. Subtract 5 pi over 4 from 5 pi over 6. Feel free to let your devices do that for you. Do so, and in return you get one last step before we finish. You can divide by -2, but there's a fraction. That interaction would be kind of weird. So I choose to instead multiply by -1/2, both the right-hand side and the left-hand side. And you distribute. So these for sure knock one another out. On this side, we'd get positive 5 pi over 24. When the negative multiplied with a plus or minus, it's still plus or minus, and the 2 went below the pi k. So find all values of theta. The assumption was they wanted radians, and we've done just that. So this is the most sophisticated answer.